So hypothesis test, we can test based on two methods. One is you compare Z standardized, okay, the two versus Z critical, okay. So if depends on if Z critical is right tail, then to fail to reject, your Z standardized has to be in a healthy area. So the bottom line is, if Z standardized falling in critical area, then we reject. If standardized test falling in healthy area, then we fail to reject. Z standardized we find based on formula x bar minus mu over sigma over square root of n, okay? So, and the same way, if you have t-test, t-score test, then you compare t standardized to t critical. So t standardized, it's going to be equal x bar minus mu s over square root of n. So again, a standardized t score has to t has to fall in the healthy area. If it fall in the t critical area, then we are rejecting the null hypothesis. Next method, this is first method. Next method, we need to that we can make decision about hypothesis test based on p-value. So if p-value less than alpha, which is the level of significance, then we reject null hypothesis. If alpha greater than p-value greater than alpha, less or equal, then greater than alpha, then we fail to reject null hypothesis. So if your claim is about null hypothesis, then this decision will be final. But if your claim is regarding alternative hypothesis, therefore you have to take the complement of null. If null hypothesis is the rejection, then your alternative will be fail to reject. If null hypothesis was fail to reject, then alternative will be reject, right? Now, how to find p-value? Alpha level of significance is given. P-value we find based on Z standardized or T standardized. You go to table, and based on Z-score or T-score, you can find p-value. So this is, I wanted to give you some template version so you would know what you are going to work with. It can ask you to find, make a decision based on critical value or based on p-value. Either way, you are going to use, so either first method or second method. All right, good luck. In this video, we are going to cover problems that involved comparison of hypothesis test using p-value to those using rejection regions. Then we will practice also finding and interpreting p-values, testing a claim about mean using critical values, using p-values, and then find critical. We will use t-score distribution. We will find the critical value in t-score, test the claim using t-score, okay, using p-value or critical value. All right, so question number 1. A certain drug is used to treat asthma. In a clinical trial of the drug, 21 out of 284 treated subjects experienced headaches based on data from the manufacturer. The accompanying calculator display shows results from the test. This is the display. Okay. Shows result from a test of the claim that less than 10%. Okay. Less than 10% of treated subjects experienced headache. Use the normal distribution as an approximation to the binomial distribution and assume 0.01 significance level. All right. So let's answer the following questions. First one. Is this test two-tailed, left-tailed, or right-tailed? So here it says less than 10%. Less than, that means we have left tail. Greater than, we would have right tail. In between would be two tails. So it is left tail. Because of this expression, less than 10% of treated subjects. Okay, left tail. Question number 2. What is test statistics? Test statistics z-score we are going to find from this given output. Here it is, test statistics. Z-score is equal, if it's not C, I'll zoom it so you can see. Z-score is equal, we are rounding to 2 decimals, right? Because Z-score we can operate with 2 decimals. It's going to be negative 1.46. Okay, what else we can find out here? What is the p-value? Okay. P-value, number 3. P-value also given from the table output, rather saying. So p-value is equal 0.07. It's right here. Okay. Anything else? What else we can read? So we need to find out what is the null hypothesis. Okay. What will be null hypothesis? Let's see. We have less than 10%, which is less than 0.1, and since it's less than, that's going to be our alternative, which means null is going to be separate proportion or probability. So less than 0.1, right? So which means null is going to be greater equal 0.1. Okay? And next question, let's say we need to decide whether to reject the null hypothesis or not, or fail to reject. So what is going to be our result? We are going to reject or fail to reject. So for that reason, we have our alpha, it is 0.01%. All right. Let me move this down. Number 5. Our alpha is 0.01, right? And our p-value, we already have it, is 0.07. Right? So because our p-value greater than our alpha, therefore we can say that fail to reject the null hypothesis because p-value is greater than significance level alpha. And final conclusion, as number 6 is going to be, so since our claim is alternative, then we are going to use the verbiage support. Let me write down here. When we have null hypothesis, then the verbiage we are using is reject. When we have alternative hypothesis, the verbiage we use is support, and you build the entire conclusion using this word, either support or reject. Now, since we are our claim is alternative, less than, so and we accordingly we have to draw conclusions regarding our claim. Let me write down, this is claim, and we said we fail to reject, right? Number 5, we fail to reject null hypothesis. Fail to reject null hypothesis based on p-value greater than alpha. So, and our claim is alternative one, this one. So if we fail to reject null, then we have to reject, right? The alternative. I don't know how to synonym to find, not to use the verbiage reject for with alternative. If we fail to reject null, then we don't support, right? Yeah, then we can say we don't support, which is no support for this one. Because here is the thing, let me explain to you. So, as you know, null and alternative are complement. So, if we accept null, then we deny alternative. If we deny null, then we accept alternative. When we say fail to reject, that means we accept it null. That means we have to deny it alternative, and that's why we put no support. Because the verb I have to use with alternative is support, okay? And the verb I have to use with null is reject. Therefore, how to put the final conclusion for that? If I'm not supporting, then I'm saying not sufficient evidence to support. The meaning is the same, we don't support. Not enough evidence to support the claim, right? That it says less than 10%. Okay? All right. I'm done with this question. Moving to next question. So, in hypothesis testing, does choosing between critical value method or the p-value method affect your conclusion? Explain. So, it's just like in, let me bring example, just like in algebra, you can solve the system of equation, for example, using algebraic method and using graphical method. Does it make any difference? No, it's still going to get the solution, correct solution, right? Therefore, same thing is here. No, because both involve, they compare test statistics and the level of significance. So in both cases, we are going to compare either test statistics or we're going to compare p-value. So no, it doesn't doesn't make any difference. Okay, number 3. Question number 3. Find p-value for the, question number 3, yeah. Find the p-value for left-tailed hypothesis test. So we have left tail hypothesis test with test statistics. Z-score is negative 178. Decide whether reject null hypothesis if level of significance is 0.05. Okay. Our alpha, let's write down. Alpha is 0.05. Right? Z-score is negative 1.78. How we are going to figure out if we are going to reject or fail to reject? So we need to find the p-value based on z-score table. So if you don't remember how to find the p-value based on z-score table, you can open in the lecture. I'll place the link under this video so you can watch how to work with z-score. But real quick, I'll remind you, so there are 2 pages of z-score table. One is for negative z-score, one for positive. So, and table works the following way. So vertically it goes down a whole number and first decimal, and horizontally goes second decimal, 0.08. Intersection will give you p-value. All right? Let me clean this. So our p-value, if you look, negative 1.78. P-value is going to be equal negative 0.0375. Okay? And to draw a conclusion, we need to compare p-value to alpha. Our p-value is less than our alpha. Hence, we reject null hypothesis. Okay? Question number 4. Find the p-value. Let me move a little bit down this. Find the p-value for indicated hypothesis test with the given standardized test statistics, Z. Decide whether to reject null hypothesis for given level of significance or not, significance level of alpha. All right. We have z-score, negative 2.5, and alpha 0.04, so it's similar to 3. So we need to find p-value for negative 0.2.5. P-value is going to be 0.0178. And then our p-value, meaning the p-value, is going to be less than alpha, let me put alpha. All right? Because 0.0178 is less than 0.04. So therefore, hence, reject null hypothesis. Next question. State whether standardized test statistics indicate that you should reject the null hypothesis. How we're going to identify if we're going to reject or fail to reject. So here we have negative 2.575. And this one is positive 2.575. If our z-score falling in this yellow area, then we fail to reject because it's a healthy area. But if it fall into this blue area, I'm trying to make it more expressive, then we reject. So we get for the first one, A, we fail to reject because it's falling between, right, in healthy area. This is 5, okay. Fail to reject first one. Second one, 5, 9, 5. 5, 9, 5 is falling in this area, right, where error is, so we reject. Next, the third one, meaning C, is negative 2.364. It's we are going to fail to reject because it's greater, it's falling in this healthy area. And the last one, we definitely reject because it's less than negative 2.575. So it's falling in this error area. 575. Okay. Question number 6. So test a claim about population mean mu at the given level of significance. Here it's given 0.06 using the given sample statistics. Okay, so what do we have? Claim is mu is equal 50, a significance level is 0.06, then standard deviation of the population 3.99, and sample statistics. Average for sample x bar is 48.7, and n, it's a sample size, is 77. So we need to first we need to identify our hypothesis test. So since our claim is mu is equal 50, which is going to be our null hypothesis, then alternative one, it's going to be mu is not equal 50, right? All right. Next, we are going to calculate standardized test statistic. Since our the hypothesis test is equal, not equal, that means we have two-tail case, right? Two-tail test, right? So next, we have to determine how much is going to be our alpha, okay? Since it's given alpha is given 0.06, since we have two-tail, then we have to split alpha half, going to be 0.03. If you have left tail or right tail, you don't split it, okay? It's only for two-tail test because we are going to have two tails for rejection area. Those are our rejection area going to be. Okay? All right. So next what we are going to do, we are going to find critical value. We are going to find, we need to find first standardized test statistics. So standardized test statistics is the z-score statistics that we calculate the given information in our word problem. So in our case, standardized test statistics formula, let me move this down. Z, this is standardized test statistics, is equal x bar, average of the sample, minus mu, average of the population, okay, and divided by sigma over square root n, where sigma is a standard deviation for the population and n is a sample size. Okay, let's plug the values and find out what we get. X bar is 48.7 minus mu is 50 and divided by sigma is 3.99 and we divide by square root of sample size, that is 77. And from that table you should get negative 1.8, here should be 0.07, which would give you Z critical plus minus 1.88. I'm sorry, here is 7.8, so rounding up 1.88. Now, let me give you a hint in a case if you have a left tail or right tail. First of all, we have plus minus because these tails, two tails, are symmetrical and equal. So once we find the Z critical for left tail with negative sign, right tail is going to be same value with positive sign. Okay, that's why once we found left tail Z critical, we put plus for right tail Z critical. Now, as you remember, Z-score table, our Z-score table, the one we use, shows left tail test only. Therefore, if our tail is going to be left, then you are fine. You take your alpha and you go find your Z-score. But if your the hypothesis test is a right tail, that means your alpha is going to be as a right tail right here. But our table shows left one. So whatever alpha you have, you are going to do 1 minus alpha to get this area, because the Z critical going to be the same anyway, right? And for this area and for this area, right? So Z critical is the same. If you go take the value of alpha to the right tail, it gives you wrong information because it will give you for the left. But to get for the left, you are going to subtract 1 minus alpha. And that probability then will give you the critical value for the left tail, okay? And whatever value it will get, critical value will get, that will be the true case. Okay. All right, so we have Z critical. Next, we need to determine the outcome and decide if we are going reject or not reject. So since our significance level is 0.06, so we can say at, So we say at 6% significance level, right? We can say there is enough or not enough evidence. Which one is going to be? So let's see. Our Z standardized test statistics is negative 2.83. Z critical is plus minus 188, which means it's going to fall in the rejection area. It's less than negative 1.88, right? Therefore, at the 6% significance level, we reject null hypothesis, and we can say that there is enough evidence to reject the claim, because the claim is null hypothesis, right? It says mu is equal 50. That's null hypothesis. So we practically compared Z standardized to, we compared to Z critical. And Z standardized falling in the rejection area. Okay. Question number 7. Use technology to help you test the claim about population mean at the given level of significance alpha using the given sample statistics. Assume population is normally distributed. Okay, we have mu is less than 1290. So that is, to my understanding, gonna be null hypothesis because equal sign is involved. Alternative one is going to be greater than. All right, next we need to find standardized test statistics. Okay, we can do that. So our formula for standardized test statistics is x bar minus mu divided by sigma over square root of n. Okay, x bar is 1 3 to 1 minus mu is 1290 divided by sigma, population standard deviation, 198.82, and we divide by n, 200. Well, how much do we get? Let me see. So 1321 minus 1290. That's going to be 31. Next, I need to take square root of 200. It's going to be about 14 and 14. So I'm writing down 198.82 divided by 14 and 1. Okay. Next, 31, and I'm dividing 198.82 by 14.14, and it's going to be 14.06, and that is going to be equal 31 divided 14.06. I'm getting 2.2. 2.2. This is standardized test statistics. Now we need to get our critical value. So to find p-value, we have to find critical value, right? So to find critical value, we are going to use our alpha, that is equal 0.04, and we have right tail. Here are two ways you can calculate your critical value. One way, remember when I had two tails, I said these tails are symmetric and equal. It's just one with negative, one with positive. So I will go take 0.04 in the z-score table with negative values, right, of z-score table, 0.04, and find how much it is. It should be 1.36, negative 1.36. That's for 1.3. Here will be 0.06. But this is for left tail. But because we have only right tail, so let me see. I'm getting the value of left tail and flip the sign. Instead of negative, I get positive. So my Z critical is going to be positive instead of negative because I have only right tail. So my Z critical positive 1.36. Okay? All right. Once we have Z critical, then we are going to find our p-value. P-value we are going to find based on standardized test statistics, which is we have the 2.2. So the probability for Z score is equal to 0.2, which is our p-value. If you look in the on the table, it's going to be 0.087. In the comments of this under this video, I will place a link to Z table video so you can see how Z score is working if you forgot about it. Okay, and lastly, we need to determine the outcome, draw conclusion. So what is our null hypothesis? Is less than 1290, and if we take our p-value let me see, our p-value 0.087, our alpha is 0.04, and our p-value is greater than alpha, which means we fail to reject. We fail to reject null hypothesis. Okay, and that's mean at 4% of significance level, there is not enough evidence to reject the claim. Not enough evidence to reject the claim. A nutritionist claims that mean tuna consumption by a person is 3.4 pounds per year. Okay, so mu is 3.4 pounds per year. A sample of 90 people, so that's going to be sample size, shows that mean tuna consumption by a person is 3.1 pounds. That's going to be X bar, right? Average for the sample. Because of the sample of 90 people, they got, after testing, they got result 3.1 pound per year. Assume that population standard deviation is 1.04, population of standard deviation 1.04 pounds. And alpha is 0.05. Would you reject the claim? Okay, so first step, we need to find out hypothesis test, right tail, left tail. Since mu is equal 3.4, then alternative test is not equal 3.4, so we have two tail. And this is our claim, right? Okay, so next we need to identify standardized test statistics, okay? Standardized test statistics, Z, is equal x bar minus mu over sigma over square root of n. X bar is 3.1, mu is 3.4, divided by sigma is 1.04, and square root of n is going to be square root of 90. Okay, and this is what we have. So 3.1 minus 3.4, we are getting negative 0.3. Next, square root of 90 is going to be 9.49. I would even say more 9.5, but would be more appropriate. 1.04 divided 9.49. Let me leave it like that. Okay. Next, I'm going to do 1.04 divided by 9.49. That is equal 0.11. So we are going to get negative 0.3 divided by 0.11. And the result is 0.3 divided by 0.11. We are getting 2.73. Okay, so our Z standardized test statistics is 2.73. Okay, so now we need to get our p-value. To find p-value, I'm going to use my standardized z-score, which is negative 2.73. Right? So p-value from here for z standardized is equal negative 2.73 is equal 0.00317. Yes. Okay, since we have two tails, this p-value is for one tail, so I need to multiply, okay, by 2, so I can compare with alpha, because alpha, since it's two tail, alpha is for two tails. So multiplying this p-value by 2, and we are getting 0.00317 times 2, and we are getting 14, 2 and 3, here is 6, 1, 1. 0.00634. Now, if our p-value is less than or equal level of significance alpha, then we reject null hypothesis. So our alpha 0.05. So our p-value is less than 0.00634, which means we reject null hypothesis. This is less than our alpha, 0.05, okay? We reject null hypothesis and there is sufficient evidence to reject the claim. And the claim is that the mean tuna consumption is 3.4 pound per year. Okay, question number 9. A company that makes cola drinks states that the mean states that mean caffeine content per 12-ounce bottle of cola is 40 milligram. Okay, mu is 40 milligram. You want to test this claim. So during your test, you find that random sample of 30 12-ounce bottles, so n is equal 12, no, 30, I'm sorry, 30 cans of cola, or 30 bottles of cola has a mean caffeine contained 41.5 milligram. Okay, that's going to be our X bar, because this founding is from 30 bottles of sample size. So 41.5 is going to be our average of the sample. Assume the population is a normal distribution and population standard deviation is 6.8 milligram, and at alpha equals 0.05. Can you reject the company's claim? Okay, so first of all, let's build the test. Since our mu is equal 40, that's a claim. We definitely can say we have two tails. Next, we need to find the critical value. Critical value we find based on alpha. It's our alpha 0.05, and we have two tails. We are going to split alpha half and get 0.025. And then go to the table, z-score table, and obviously we are going to look into negative z-score table because it's less than 50%. So, and in negative the z-score table, we will find that z critical for alpha half is equal 0.025 is negative 1.96. Now, remember I told you, since we have two tails, the value is the same. It just sign is different. This negative 1.96 here will be positive 1.96. So I can put plus minus 1.96. Okay, now next we need to identify the rejection area. So since we have plus minus 1.96, then these blue shaded colors are going to be a rejection area, and this one is going to be fail to reject. Okay, area. Okay, next we need to find standardized statistics. Standardized statistics we find based on calculation. So our z-score, z standardized, is equal x bar minus mu over sigma divided by square root of n. X bar is 41.5 minus mu is 40, divide by sigma 6.8, and we divide by square root of 30. Okay, let's see how much we're going to get. So 41.5 minus 40 is going to be equal 1.5. And we are going to divide square root of 30. It's going to be 45. No, 30. Okay. 5.48. And then 6.8. We divide by, okay, by 5.48, and we are getting 1.24. And here 1.5, and 1.5 divided by 1.24 is equal 1.21. Let me move it here. It looks messy. Okay. So we are going 1.21, and that's a standardized test statistics. And so from here, we need to find out also whether we can reject or fail to reject null hypothesis. So where I'm going to take z-score and see this our standardized z-score compared to z-critical and see if it's in the failing area or not. So 1.21, it's gonna fail. It's gonna fall in the fail to reject area. Therefore, we are saying, because look, z standardized is 1.21 and z critical is plus minus 1.96. It's falling right in between, right? That's why we are saying that there is not enough evidence to reject the company's claim. Okay, that's all. All right, moving to question number 10. A company claims that mean monthly residential electricity consumption in a certain region is more than 800 kilowatt hours. Okay. Looks like we have right tail, more than. So mu is more than 880. You want to test the claim. You find the random sample n is equal 63. That sample size. Mean monthly consumption, meaning x bar, is 910. Assume the population standard deviation, sigma, is where is it? Sigma is 130. At alpha equals 0.01, can we support the claim? Okay. Did you notice it doesn't say can we reject, it says can we support? Why? Because the claim is alternative hypothesis, and alternative hypothesis dealing with support. Okay, so first let's write down what we have. So null hypothesis is going to be mu is less equal 880, and alternative mu is greater than 880. Okay, next find the critical value. Critical value we're going to find through alpha, right? So we have right tail. So which means although our z-score is going to be negative, but we are going to flip and get positive. Again, because this is right tail, the left tail, they are equal. It's just this one negative, this one is positive. Since alpha 0.01, it's less than 50%, then it's going to be negative. Well, we just flip the sign, and that will be our right tail. Or you can do 1 minus 0.01, then go take the z-score from the z-score table. So in this case, if you do 1 minus 0.01, it's going to be 99.99. Okay? All right, so from here, what we are doing, to find critical value, I'm going into table and trying to find z-score for 0.01 and z-score critical for alpha equal 0.01. It's going to be equal to 2.33. It will be negative 2.33, but because mine is right tail, I put positive 2.33. Okay, so this is our critical value. Next, I need to identify the rejection area. So here we don't have to go through p-value. We just need to identify through comparing z critical to z standardized statistics. So let's find z standardized statistics, which is we find through calculation. That is equal 910 minus 880 over, how much we have here, 130, and we divide by 63. And we are getting, so I did the math and I got standardized test statistics 1.83. So I am comparing to critical value, that is 2.33, and we have right tail. That means, since we have right tail, that means we fail to reject if the standardized test statistic is less than, right, than z critical. And we have z is less than z critical, which means, so this is 2.33, and this is our 1.83. But that means fail to reject. To reject null hypothesis. Okay? Because standardized test statistics is not in the rejection region. Okay? Next question, number 11. A fast food restaurant estimates that mean sodium content in one of the breakfast sandwiches is no more than 910. Okay, so mu, no more, which means it's going to be less equal. So, and that's going to be our null hypothesis. Random sample of 35 breakfast sandwiches, which is going to be, okay, let me might as well write down, mu is greater than 910, and this is our claim. Okay, next we have n is equal 35. Breakfast sandwiches has a mean sodium, so average of this n, 35. That's why I put x bar, because it's a sample mean, and it's equal 905 milligram. Assume population standard deviation is 22 milligram, alpha is 0.1. Do we have enough evidence to reject restaurant claim? Okay, let's go. Here we have the hypothesis test. I already built it. Now we need to identify critical value. As you know, critical value we identify through alpha. We have what? We have right tail. So which means we can find z critical using our alpha 0.1. Let me see if I find alpha 0.1. I don't have the table. Oh, here it is. I found it, 0.1. So z critical is going to be equal 1.28. So on the negative page of z-score, you find the z-score for probability 0.1. So it's going to be 1.28. Next, we need to find rejection region. Okay, so what is going to be rejection region? Because we have right tail, and our z critical is 1.28. So this is rejection region. So rejection region is going to be z critical greater than 1.28, right? Okay. All right. And we need to find standardized test statistics, z-score, which is again going to be, let me see, 905 minus mu, which is 910, divided by sigma 22 over square root of 35. So square root of 35 let me see, 5.9 and we have 905 minus 910, it's going to be negative 5, right? And we have to divide 22 by 5.9. That's going to be 3.73. And 5 divided by 3.73. And that is 1.34, negative 1.34. Okay, so this is going to be our standardized test statistics. All right, so if we take compare standardized test statistics to the z critical, what we can see, our z standardized is going to be less than z critical, right? Because negative 1.34 is less than 1.28, which is falling in the healthy area, right? Fail to reject area. From here, we say we fail to reject. Null hypothesis. There is no sufficient evidence to reject because null hypothesis is associated with reject verbiage. And the rest you can build yourself the sentence. Okay, number 12. Explain how to find critical value for T distribution. Okay, very easy. First step, we need to find degree of freedom, n minus 1, okay? And then once you open t-score table, so vertically going degree of freedom, horizontally it's going, you can choose either confidence level, or you can choose one tail, or you can choose two tails, depends on what you have. And you choose accordingly the percentage of confidence interval, or right tail, one tail, or two tails. So if you have one tail test, then confidence interval is 95. Confidence interval is 95%. Then one tail is going to be 5%, right? 100 minus 95, 5%. But if you have two-tail test, then you will divide for two-tail test. You can divide 5 by 2, 2.5%. Okay, and find intersection. All right. So if the hypothesis test turned out to be left-tailed, then we are going to use one tail, and we use negative sign because, remember, left tail, it's always going to be end up critical value going to be negative. And if it's right tail, and then it's going to end up with positive. But if it's two tail, we're going to end up with positive and negative. Okay, next question, number 13. Find the critical value in rejection region for indicated t-test, level of significance alpha, and sample size n. So, what do we have? So, our alpha 0.005 and n is equal 27. So, we have degree of freedom, 26. Alpha, we have 0.05. Because it's a left tail, you need to look at for one tail, right? It's going to be one tail, and because it's left, so T critical is going to be less, and left tail is going to be negative. So let me find 26, and it's going to be less than negative 2.779. Okay. Next, find critical value. So we have here right tail. That means our T critical is going to be greater than. So in alpha 0.01, it's going to be one tail, right? And degree of freedom is going to be equal 7. So if I'm looking on the table, degree of freedom is 7, and one tail 0.01, it's a okay, and 7, I'm getting greater than 2.998. Yeah, okay. Number 15. Find the critical value and rejection area for indicated test. Level of significance is alpha. So we have two tail. Alpha is equal 0.01, n is equal 23. So because we have two tail test, we are going to divide by half. We take alpha half, it's going to be 0.005, right? 0.005, and degree of freedom is going to be 22. Therefore, we are going to have, let me look it up, 0.005 and 22. It's going to be 2.819. So because we have two tail, so it's going to be T critical is going to be less than negative 2.819, and T critical is going to be greater than positive 2.819. We are looking in the tails, right? So a negative one and positive one. Okay. Next question, number 16. Use t-test to test the claim about population mean at the given level of significance alpha using given sample statistics. Assume the population is normally distributed. So the claim, we have two tail, obviously. So mu is equal 51,900. And alternative, mu is not equal 51,900. Okay, alpha is equal 0.01. Sample statistics, x bar that's average of the sample, 52,555. S is a standard deviation of the sample. Remember, a standard deviation of the population is sigma, but for sample is S. And N, sample size, is equal 17. Okay, we need to write down first our hypothesis test, null and alternative. We already have it. So this is our hypothesis test. We have two-tail test. Okay, and next question, what is the value of standardized statistics? For t-test, standardized statistics formula is equal x bar minus mu over S divided by square root of n instead of sigma. Okay, and this is gonna be equal, x bar is 52,555 minus mu, it's gonna be 51,900 divided by S is 1,400 and divided by square root of 17. Okay, so we are getting standardized test statistics. Let me do the math. So square root of 17, I'm getting 4.12, and then 1,400, and here we have 52555 minus 51900, we are getting 655. So from here, 1400 divided by 4.12, I'm getting 339.8 and 655 in numerator, and result is going to be, let me see, so 655 divided by 339.8, and we are getting 1.93. 1.93. Okay, next we need to determine the degree of freedom, because we want to find the critical value, so we need to get degree of freedom. So our n is how much? 17, so degree of freedom is going to be 16, right? So n minus 1, it's going to be equal 16, and we have two-tail with alpha 0.01. Okay, so degree of freedom 16 and two-tail 0.01, that's the last column, and 16, so 2.921, 2.921. So T critical is equal 2.921 negative and positive 2.921. Okay, so from here we are going to have, we have already critical value and we have standardized test statistics. So we can compare and see what result we get. So this is negative 2.9 approximately. This is positive 2.9, and our test statistics 1.93 somewhere here. So we fail to reject null hypothesis, right? Fail to reject null hypothesis. And there is not enough evidence to reject the claim. not enough evidence to reject the claim. Okay. Number 18. Use technology and t-test to test the claim about population mean at the given level of significance level using, so same thing. It's going to be same thing. We have alpha equals 0.05. What else? X bar is 76.7, S is equal 3.6, N is equal 27. Our mu, so it's we are given alternative 1. Mu is greater than 74, which means we are dealing with right tail, right? And null hypothesis is going to be mu is less equal 74. Okay, so let's start working on this case. So we need to find standardized test statistics, right? So it's going to be T standardized. It's going to be equal X bar minus mu over S divided by 27, okay, divided by N. So this is equal, X bar is 76.7 minus mu is 74 divided by S is 3.6 and divided by square root 27. Okay, so let's start square root 27. How much is it? $5.2. 3.6 divided 5.2. 76.7 minus 74. It's going to be 2.7. Okay, so from here we get 3.6 divided by 5.2. I am getting 0.7. 0.69. Okay, 0.7. Well, okay, let me put 69. And 2.7. So from here, T is going to be equal 2.7 divided by 0.69 is equal 3.9. Okay, so this is standardized test statistics. Now we need to find our p-value because we want to compare p-value to our alpha. Okay, my standardized test statistics is 3.9. Based on that, I'm going to find p-value. So why did I put so there is enough evidence to support the claim? Because our claim is alternative, right? This is our claim. Here it is. It says greater than, which is, oops. I thought this one is alternative. No, this one is alternative. This is our claim. My handwriting is just horrible. Okay, this is our claim, and it's a right tail test. And since we reject null hypothesis, that means since alternative one is a complement to null, that means rejection of null, that means fail to reject alternative, or we support alternative, right? Therefore, since we rejected a null hypothesis, then we support the claim for alternative, and there is enough evidence to support. So here is working like that. When p-value is less than alpha, then we reject null hypothesis. If p-value greater than alpha, we fail to reject null hypothesis. Okay, moving to the question number 18. Okay. Use a t-test to test the claim about population mean. So it's the same thing. We have mu greater equal null hypothesis. Mu is greater equal 8,300. Accordingly, alternative mu is less equal 8,300. And null hypothesis is our claim. Sample statistics S bar, X bar is 8100. S is 460, N is 22. Okay, so we already have the hypothesis test placed, so you have it here already. So next we need to find out standardized statistics, which is going to be, again, same thing, X bar minus mu over S divided by square root of N, right? So that is equal 8100 minus mu is 8300. Dividing by S is 460 divided by square root of 22. Okay. What do we get here? Let me see. (22) square root. It's going to be 4.69, 460, and then negative 8,300 minus 8,100. It's going to be negative 200. And then we have 460 divided by 4.69. It's going to be 98.08. And here is negative 200. And 200 divided by 98.08, we are getting 2.04. Negative. Oops. I'll add negative sign. All right. Negative 2.04. This is our standardized test statistics. Okay, we need to find p-value. I am going to use the p-value calculator online. So t-score, I'm plugging negative 2.04. What else? Degree of freedom is how much? 22, so it's going to be 21. And then significance level is 0.01. And we have one tail. Okay, so click calculation, and we are getting p-value. I'm getting 0.27. All right, so let's compare. Now, p-value is 0.27, my alpha is 0.01. So my p-value is greater than my alpha, right? So then that means we fail to reject. If p-value greater, in my case it is greater, 0.01, yeah, then we fail to reject null hypothesis. And I don't need from here to switch to alternative one because null hypothesis is my claim. Okay, and we can say there is not enough evidence to reject. Okay? At 1% significance level. And the last one, okay, it's absolutely same way. You can look, see number 18 or 17 or 16, it's the same thing. All right, I'm done.